morning, everyone. Thanks for coming. I guess the presentation today is about some of the stuff that we learned at Sangoma Engineering by playing around with Asterisk and WebRTC. I mean, we do not have any products or services yet on the WebRTC space, but we think it's a promising technology, and we've been using it in-house. We want to allow our customers to reach to us through our web page in the easiest possible way. So we've been playing around with this technology in Asterisk, and today I wanted to talk to you a little bit WebRTC introduction. I know you had already some sessions about WebRTC yesterday, so some of this information some of you may have heard before. I'm going to try to skim to that as fast as possible to get into the into the meat of how to implement WebRTC in Asterisk and some of the problems that you may face and how to solve them. Okay, we're going to go through the install and config and some troubleshooting. So I guess the first thing that I wanted to mention is that the easiest analogy to do about WebRTC is saying that it's like a phone in a web browser, right? And it's easy to understand, and it's a good analogy. But I guess we got to stop looking at it as just a phone in the web browser, right? There is much more to it than just a phone. It's a full real-time communications engine in the browser. So what this means is that, yes, you can build a phone with it, but you can also build many other type of applications, real-time communication applications, by just using JavaScript, right? Before WebRTC, you had to use either Flash or some ActiveX stuff, some plugins and whatnot. So what Google and all the other browser vendors are doing is basically putting codecs and all these kind of media-related stacks into the web browser. So yes, you can build a phone in the browser, and that's if you go to the WebRTC shows and all of that, that's a very common demo. But there is also some more applications that some of you may have heard of in the other sessions, and that we may mention later in this presentation. So there is, as I said, there is a full media engine in the API in the browser. We're going to touch a little bit about the APIs that are exposed to you. If you're a web developer, you're used to use JavaScript for your development. It's pretty much the same. It's just a different API in JavaScript, so you can manipulate the media streams, send media settings from one browser to another. There is a generic data interchange in between browsers, so you can not just exchange media, but you can exchange any kind of data that you may want for your application, peer-to-peer, browser-to-browser. And it has state-of-the-art natural reversal techniques. Some of you may have heard about ICE. So that's the technology that WebRTC is using. All of these technologies kind of already exist. It's not particularly nothing that didn't exist before, but now they are integrated in the web browser, and they're making it easy for web developers to use them through JavaScript APIs, right? Which is it's opening communications innovations to web developers, which there are zillions out there, and they are very creative, and we're just hoping what kind of technology, what kind of applications they're going to build with these APIs, right? So the main API, there's a variety of APIs that the WebRTC exposes, but I guess these are the four main or the ones that as a web developer you're going to be working on. Is the peer-to-peer connections, the RTC peer connection class, which basically is the main one that allows you to connect, create a peer-to-peer link between two browsers, right? There is a peer-to-peer data API, which, as I said, allows you to exchange generic data, such as for video games, synchronization between one browser and another, what thing is happening in one web browser, and what is happening in another web browser. There is statistics. You're going to need this if you're doing any kind of troubleshooting. You want to see if you're having packet loss, jitter, or all these things all these metrics that you should worry about when you're dealing with voice. You have an API to pull them from the media stack. And there is, of course, the media stream, which allows you to access the user media, right? It allows you to access the camera in the computer. It allows you to access the microphone. So from the web page, without any plugins, again, I reiterate that fact, you can, with a JavaScript API, request for the video camera and then send that feed elsewhere, right? It can be to another browser or it could be elsewhere, right? It's not just about phone calls. These are the protocols that are behind WebRTC, right? We have some of them you may know already if you've been around in the Asterisk community. I mean, and if you have some background in voice over IP, some of those protocols you may know already. SRTP, SRTCP is used for media exchange. So it's just an encryption layer on top of RTP, so you can have secure communications by default. So that's another great thing about WebRTC is that they went all about security in WebRTC. I mean, most of VoIP deployments to these days, they still use SIP over UDP, right? Even though we have TLS, even though we have SRTP, most VoIP deployments are still going out with good old SIP over UDP, right? Unencrypted, all your information is in the plane. Anyone can see both the signaling and then on the media side, the RTP signaling, so they can actually listen to your conversations, right? The good thing about WebRTC is that now has security built in, and it's actually mandatory to enable the encryption, right? So when you have a peer-to-peer communication between two web browsers, you can have it secure using SRTP. The use of SDP, for those not familiar with SDP, SDP is what is used for communicating the capabilities, which codecs one user agent supports, and which other media sec. So that's the way two SIP user agents, or in this case, two web browsers, can exchange capabilities and decide which codec they are going to use or which other session settings they are going to use, right? Now, the use of SDP has been kind of controversial on the WebRTC standard because it doesn't fit all that well on the web model, right? Web developers see the SDP as this old stuff, cryptic, hard to use, and it is, right? So if you compare it with the most web technologies, it's a lot more cryptic and hard to work with. So the use of SDP is kind of challenged right now. There's some people that would like to have a more pure JavaScript API to exchange this kind of capabilities between web browsers. But it is unlikely that for the first version of WebRTC, we're going to see change there. So SDP, for good or bad, is really here to stay for the first version. ICE stand turn are used for NAT traversal. I'm not going to go into details for that. Let's just assume that they are the magic that allows you to have two web browsers behind NAT and still be able to talk to each other even though there is a firewall in the middle, right? We have DTLS for key exchange. On the VoIP world, again, for those familiar with the VoIP world, usually the key exchange is done in the SDP. It's done in the SIP. During the SIP signaling, you can exchange your key, your encryption key, and then you can start encrypting the RTP and convert it into SRTP, right? For WebRTC, because everything is about media, DTLS already exists before. I think they did a lot of work to get it to work more mainstream into WebRTC. But now the key exchange it can go into the media path. So that's important because, again, it allows you to do pure peer-to-peer without having to rely on someone in the middle who can potentially see your encryption key, and now it can decrypt your media, right? And on the codec side, we have the good old G711 who appears to never die. He's making it into WebRTC. We have Opus, BP8, and H.264. There is some words there about which codecs should be mandatory, which not. But those are the codecs that you're more likely to encounter if you deal with WebRTC. So now, the question, what signaling to use? That is really up to you, and that was the intention of the WebRTC designers, right? To not force you to use a particular type of signaling, which I think it was the right decision, right? Because VoIP guys love SIP, well, as much as you can love SIP, and they understand it, and they like it. But web developers may find that zip is a little bit of an overhead when you just want two web browsers exchanging a video stream or an audio stream, right? And if you don't need all the heavy capabilities of zip, zip is meant to be used in a lot of network in the zip in the core telephony network in a bunch of different scenarios. So it can get complicated, right? So you have other options. You can use your own RESTful API, your own application to exchange these SDP blobs that the web browsers generate. You can use known signals such as zip. There is already guys that work very hard on getting a minimalistic zip stack that you can embed in your web page. So this is basically a small JavaScript library that you just pull, and then you can start using it to as a zip stack embedded in the web browser, right? So it can get painful to understand. If you're not familiar with zip, you're going to see a lot of information in the zip traces that you may not be able to understand. So a little bit of reading of zip will go a long way if you're developing if you're a web developer and you want to develop applications with WebRTC and you're going to use one of these JavaScript zip signals, you're going to have to learn the protocol, right? There is XMPP jingle, and there is another one, an interesting one, which is OpenPeer, which is proposed as a peer-to-peer signaling for WebRTC. I don't know much about it. I kind of throw it in because I think it's a cool project, and I think you guys should check it out as well. It seems interesting. So applications, aside from a phone and video calls, right? You can go to the web page webrtchacks.org, and there's a bunch of other ones that have a bunch of demos with some demos that I didn't even think about, such as a motion detection baby monitor, right? Where you have a JavaScript application that is monitoring a video stream, and then it can detect when there is change in that video stream, and it has a threshold to decide how much movement you want to get notified about, right? Because maybe if the baby just move a little bit, you don't want to get alert. But if there is a lot of movement, you want to get notified about, and then you can also see, and you can monitor your kids or whatever, right? So I think that's a good application. There is of course Chromecast. For those who have not heard about Chromecast, it's a small USB dongle that you can plug into your high definition TV, and then you can stream anything from your computer to your TV, right? So it's kind of like a Pursman Apple TV, right? So it allows you, and the word on the web is that they are using WebRTC for that streaming. I haven't done any packet capture to verify if that's true, but it's very possible that they are using WebRTC for this application. I wouldn't see what other technology they will be using, right? So this is how it looks like. You have basically your web application somewhere in the cloud, and then you have two web browsers talking to each other, peer-to-peer media. The signaling goes through your website, whatever signaling you decide to use, right? Now, when we talk about WebRTC into Asterisk, the topology, there's different topologies, but this is one of the ones that you could see, right? You're going to put Asterisk in the middle. The web application doesn't need to run into Asterisk. It doesn't have to be even in the same web server, of course, on the same server. It doesn't. And this is just one. Again, in this case, in this diagram, I am mentioning zip over WebSockets, right? Which is the easiest way to get zip into the browser, right? Basically means all the zip signaling is going to go over the WebSockets HTTP technology, right? And Asterisk has a web server embedded to be able to receive the WebSocket signaling and then pass it up to the zip stack. Now, putting WebRTC into Asterisk, the nature of Asterisk makes it that it's very easy now to have a WebRTC gateway from WebRTC to all the other protocols that Asterisk already support, right? That's the great thing about Asterisk, which has support for a lot of protocols. And now they added WebRTC, so now you can have a browser talking to zip lines, to FXO, FXS, good old plain old telephony, to PRI, to SS7. So Asterisk is like this gateway that can connect you to pretty much any other telephony technology that is out there, right? So with the addition of WebRTC into Asterisk, you can do that now. And this is how the more low-level components look like. On the web browser, you're going to have a JavaScript zip stack, or it could be some other, again, it could be some other signaling stack. But for the case of Asterisk, Asterisk talks zip over WebSocket, so you're going to need a JavaScript zip stack. There's a couple of them out there. And on the Asterisk side, you're going to need, of course, ShadZip and a bunch of other modules that are already in Asterisk 11, such as REST HTTP WebSocket, which is the one that takes care of receiving the WebSocket connections and then handing them over to the zip stack, right? The technologies that we use, particularly at Sangoma, were Asterisk 11, and we decided on the zipML 5 stack, JavaScript stack. And all the testing one does use Chrome Theory, but any recent version, I mean, Chrome auto updates very frequently, so you're most likely to be running the latest version of Chrome already. You can use Firefox as well. There is one thing with Firefox, they are because the WebRTC standard made DTLS and secure media mandatory. Firefox by default defaults to that. Whereas suppose Chrome seems to make it optional, right? If you expose it, it's going to use secure media. If you don't, it's going to use non-secure media. So you got to always verify in the traces what you're using. So when installing WebRTC supporting to Asterisk, these are the three things that you should make sure you have in the host where you're compiling Asterisk, assuming you're compiling it. I don't know how much people still compile Asterisk. It's like most people compile Asterisk still, yeah? Okay, so if you're compiling Asterisk, you're going to have to make sure that you have libuUID level, OpenSSL with DTLS support, so you need a recent version on OpenSSL, and the libsRTP development headers. The compilation steps are pretty standard, right, for almost new applications. Configure, make, install. Just make sure that when you do make menu select, it's a great way to go and verify that you have the needed libraries for the RTP libuUID. If you don't install libuUID and you make menu select, you will see that the rest RTP Asterisk stack is not going to be compiled, and you're going to start having some cryptic errors at the time when a connection comes in because there is no RTP stack, right? So starting from bottom up, the first thing you got to do after you install Asterisk is you should enable the WebSocket supporting the. So Asterisk has a web server embedded, right? A custom web server embedded that is able to process HTTP requests. So you got to configure it, you got to enable it. And in the case, it's recommended if you want secure communications on the signaling side, you got to enable TLS, right, on the http.conf server. And you're going to have to have your certificate. You can use a self-signed certificate for that. So using TLS, it is, as I said, it is the way to go if you want security. It's going to complicate things a little bit because now you need to, if you're not already familiar with TLS, now you need to generate your self-signed certificate. You can generate a certificate request and all these steps. There's quite good documentation at the Asterisk Wiki about how to do that. So you should be able to get it going. But it's going to also complicate, unfortunately, and I think that's the reason most people still in the zip world sometimes do not use TLS. They still use zip over UDP, is that it complicates troubleshooting, right? Every time you want to do a packet capture or anything, you're going to have to go through some steps to be able to decrypt those traces and see what's going on, right? Whereas if you're using just zip over UDP, you can just watch it right away in Washer, right? Or any other packet analyzer. So for starters, I would recommend you guys, if you're just starting, you should use just zip over WebSockets without encryption while you get your first calls going on. Once you know things are working, then you can start to move to the TLS. And that's a lesson that we learned on the hard way because we started going to TLS and things were not working. And we just assumed that we were doing something wrong. And we scratched our heads. We went back and forth documentation, trying to decrypt the signaling, see what we were doing wrong. And It seems to be a current bug in Asterisk, at least in Asterisk 11. I think I tried Asterisk 12 as well, and I saw the same behavior. And it seems secure WebSockets are not quite working. They may work sometimes. Sometimes the socket will not really receive all the data that it's supposed to receive, and your call will hang. There is already some patches that we post on the issues.asterisk.org web tracker. There's a link there. And there is a branch who has the changes that we did to be able to fix that problem on the SVN and the SVN, DUM's SVN server, right? So if you're trying to use TLS secure WebSockets and it's not working, you're most likely hitting this bug. Don't spend like a week trying to get it configured properly. Better just check out the issues asterisk.org, and you'll find there the patches or the SVN branch that you can use. After you enable that, you make sure that it's actually your configuration was actually taken. So that's easy to do with the HTTP show status command. So that's Asterisk is going to show you the status of the HTTP server. It's going to tell you if it's listening only on which IP address and port is listening for connections, and it's going to tell you if the secure HTTP server is enabled or not. So this is the first thing you got to do to make sure that before you even try to connect to Asterisk, you got to make sure that Asterisk knows where it's supposed to listen. Now, before you start placing calls, there is this handy utility from the Node community. This is called WSCat, which is like a small test JavaScript binary, if you can call it that way. It's more like an application that you can use to test the WebSocket connection, right? It's an echo server. So you connect, you execute any of these commands for both the unsecure version and the secure version, and you are able to test any WebSocket server, including the WebSocket server that is embedded into Asterisk. So this is highly recommended to do. So you can first verify that you have the WebSocket layer working. So you can just do this, and everything you type is going to be echoed back by Asterisk, right? Asterisk has a built-in echo protocol, if you can call it that way, built on top of WebSockets to simply echo back whatever you type. So you type something, so now you have end-to-end communication between your browser, or in this case, your computer, and Asterisk using WebSockets. And of course, if you're curious, you can also use Wireshark, and you should be able to see the HTTP connection going into Asterisk and asking for an upgrade to a WebSockets connection. And then Asterisk replying and saying, granting that switch to WebSockets, and then the actual data for the WebSocket frames. After you verify that you have your WebSockets connection working, now you want to go to the higher layer, which is SIP. You want to go to sip.conf and enable the WebSockets transport, right? So it's just like any other transport that Asterisk arrays for. You just got to put it in the transport keyword. And make sure that when you connect to Asterisk, you use the /ws URL, because that's what tells the web server that it needs to send the connection to the WebSocket handler. And finally, creating a SIP account to receive WebSocket calls. That's all you have to do. The Asterisk developers make it very easy. It's simply enabling your HTTP server WebSocket connection, and then enabling it in the SIP driver. So now you will find out that you have a bunch of options to test your development. Even before you start writing any JavaScript code, you can just go to a web page such as this, zipml5.org, and they have WebRTC phone built in there. So you can just use it as a test bed to send calls to your server, and making sure that you're not making any JavaScript mistakes, right? These guys got it right. They are doing it right, and it works. So that's one way of quickly testing if your configuration in Asterisk for WebSockets is working adequately, and you have WebSockets enabled on SIP as well. So as with any other Asterisk SIP traces, you are able to enable SIP set debug on, which is going to be You're going to have to do it if you want to troubleshoot any kind of issues with WebSockets Asterisk SIP support. And you want to be able to see that the packet is read from the WebSocket address, WS. So that's the hint that you can see that the packet is actually being received through the WebSocket layer. So now troubleshooting. All of this stuff probably you will make some mistakes along the way. That's the usual stuff. That's how it goes. And you got to use the JavaScript console. If you're a web developer, probably you're laughing at me right now because that's something that every web developers know, right? I'm not a web developer, so when I started with this thing, I didn't even know about the JavaScript console, and I was trying to do Wireshark traces and whatnot, complicating things. And yeah, of course, you go to the JavaScript console, and you will see very nice all the zip packets that are going out from the web browser towards the Asterisk server are traced there. There is this nice web page on Chrome WebRTC internals URL. And it gives you an amazing amount of information about all the WebRTC stuff that's going on when you have a call in place. We're going to see some screenshots ahead. I mentioned already the Node WS for testing WebSockets. And of course, if all of the above fail, then you can always get the trusted Wireshark. This is just a screenshot of the JavaScript console for those of you that may not be web developers. So it's just a little console that opens in your web browser, so you can see all the activity that is happening in your JavaScript and whatnot. If you go to the Chrome WebRTC internals, there is a bunch of stuff, as I said. These graphs are nice to be able to see if you're actually receiving and sending packets at the media layer. It's going to tell you the bit sends and bit receives per second. If you don't see anything there, then something else is wrong. Somehow you're not receiving the packet. Somehow maybe you have a very aggressive firewall somewhere, or you did something else wrong that is causing that there is no media between you and the other endpoint. So on other stuff you can check out. I didn't highlight here. I forgot. There is things to check. The audio input level. That's the input of the microphone of the computer, right? So if you see a 0 there, there's either nobody's talking on the microphone, or something is wrong with the microphone, and there is the web browser is not capable of receiving the input from the microphone. There is byte sends and packet send counters there as well. There is the codec that was negotiated for that particular call. So you can see a bunch of things that may hint you about what is not working if you're having problems. Or if you're just curious about what you're using, sometimes you may be thinking that you're testing the Opus codec, and then you find out that you're really using PCMU, right? And so you're not testing really Opus. So as I said, if all of that fails, you can always fall back to the trusty Wireshark. The only problem with Wireshark is that WebRTC being new and all, Wireshark doesn't support the sectors for some of the technologies that are involving WebRTC, such as the RTCP muxing, which is basically RTCP packets embedded in the RTP stream. And so if you try to listen to the RTP media using Wireshark, you won't be able to do it. The decoder will go crazy, and it will play just some noise instead of playing the actual media. But you can, however, use stuff such as follow TCP stream, which always work, and that way you can see that the packets are actually leaving your computer or actually arriving into your computer for sure. Because the fact that you don't see them in the web browser doesn't necessarily mean that they are not arriving at your computer. Something else could be wrong between your web browser and the IP layer, right? So that's something good to test. If you go to the VoIP call menus, it won't work either because, again, one, the signaling could be encrypted. Two, it seems the VoIP calls menu doesn't know about WebSockets, SIP over WebSockets yet. So it's not able to detect that there was some VoIP calls working in the trace. For the decryption part, you can at least try to partially solve it, at least for the signaling part, by going into the Wireshark preferences, protocols, SSL, and then you're going to need the private key. So that's something you can access to if you're using self-signed certificates and you have access to your web browser. you usually can access the private key and load it into Wireshark, and then you should be able to decrypt the WebSocket signaling. But if you don't have access to the private key of your web server, whatever web server you're using, or maybe you're not in charge of the web application and you don't have access to that private key, then you're out of luck, right? You will have to use something else. Yep, this is just the Wireshark decrypted secure WebSocket payload. So once you load this key, you will see that it's a TLS record, but Wireshark is able to decode the payload, which probably you cannot see from where you are standing, but the payload side has the full zip packet in there. You can just copy and paste it, export it, or so you can analyze it. So we're almost approaching the end of the presentation. So some things to test in the near future that I would like to test, or I would like some more people testing and providing feedback on, is the trickle ice technology. I was just reading about it, and it seemed interesting because at the beginning of the WebRTC call, sometimes there is a little delay because the NAT traversal techniques that are used for being able to bypass NAT, they may take a few seconds to adjust to find out the reliable path. So there is a little delay when you place a call. And this thing is supposed to be able to solve it. I haven't looked at it. I don't even know if Asterisk supports it. But it's something interesting to look and read about. Use of other codecs such as Opus and ISAC. That's something else that and of course for video VP8. And finally, another thing that I like to look at and maybe get some feedback from any developers that are in the room. It's about using lib WebSockets in Asterisk, which is a LGPL library. I found very weird that the Asterisk developers decided to write their own WebSockets implementation, which I guess was part of the problem that I was facing. But it may be some licensing issues or some other stuff that I'm not aware of. But I would like to talk to any, if there's any developers that know about that, I'd like to talk about it. And in conclusion, Asterisk and WebRTC Gateway is very easy to set up, aside from the little bumps that we hit with the secure WebSockets. Everything else was very straightforward. The documentation on the website on the wiki for Asterisk is enough to get it working. There's still missing bits and pieces, so feel free to contribute more documentation. We always need more. You got to know your debugging tools, as I described during the presentation. Otherwise, you're going to run into issues, and you will know what to do, right? So try to dig a little bit more on the debugging tools that are available. And as time goes on, I know Wireshark will get better for decoding WebRTC calls and all that kind of stuff, so things will get easier. And this is just an invitation for everybody to just download Asterisk and start trying the WebRTC support. Thank you.
All right, we've still got a few minutes, so we're going to open the floor for questions. Does anybody have a question that they would like to ask Moises? I've got oh, we do. So I don't have to give away this candy. I'm going to keep it.
Could you elaborate more about how the WebRTC internals page works? Does it just go, do you have to start, does it just show information about the most recent call made, or how do you tell it which call to look at?
Yep. So, well, you just have to, typically the way that you just open another tab in the Chrome browser, you go to that URL, chrome://WebRTC internals. And as soon as you place a call, it's pretty much like the JavaScript console as well, right? It's real time. So if you in another tab, you place a call to a WebSocket server, you start using WebRTC, you're going to start seeing all these statistics played. If you place a call in the past and you do WebRTC internals, you also will be able to see some history about the previous network connections that were placed. So the way I use it is usually in real time because I debug stuff in real time. I don't know how much of a history Chrome is going to left there. I didn't test that. But yes, even if you hang up the call already and you go there, you will be able to see still some statistics, right?
I tried WebRTC with Chrome and Asterisk several times, using Asterisk 11, several versions, and also Asterisk 12. and the WebSocket part was always easy and running, but I always had problems with audio. So sometimes I had just one-way audio or no audio at all, and I stopped playing around with it because I thought, okay, I didn't find out if it was Chrome or Asterisk or.
Yeah.
So I just playing around with it because I couldn't find a solution and was it took me too much time, so I stopped because I got the feeling it's not ready to use it yet.
Yeah,
So what do you
I
think?
guess it depends on the definition of use. It's not it may not be WebRTC is a moving target, right? So browsers are updating their implementations every day. Asterisk is changing stuff it's a hot project, right? It's changing the RTP internals, it's changing stuff. So when you're changing the implementation of the web browsers and changing the implementation of the other engine, some things are meant to break sometimes. So it's definitely not something that you just install and it's going to work right away. Sometimes you will have to work out the right versions, right? I find that things are getting much more stable. But having said that, I just experienced the issue that you just mentioned, right? With Asterisk 11 the latest stable version, it works fine. But then I started going to the latest SVN branch from Asterisk 11 still, which is the candidate for becoming the next stable release for Asterisk 11, and I got no audio, right? So I got no audio. I'm still looking at it. I'm trying to. I guess at this point we need those kinds of reports, and we need people that can create debugging information, because just saying, oh, it doesn't work, guys, it doesn't help much the Asterisk developers. We gotta provide constructive feedback. Go to the issues asterisk.org issue tracker, describe your issue, and just as in my case, I found a solution. It's posted there. So it's just at some point it will get merged into the stable version of Asterisk, and it's going to get better. That's what I can say. It's going to get better, but we need more people trying it and more people giving reports such as yourself.
All right, we are all out of time for questions right now. I'm sorry, but if you do have additional ones for Moises, you can ask him in just a few minutes at the back of the room. We've also got these comment cards here. If you'd like to fill them out, that'd be great. Tell us how Moises did. If he did really wonderfully, let us know. Put it in the box in the back. If you did terrible, don't tell us.
Don't say it. Yeah. Good.
Thank you very much.